Hello friends, so in today's lecture we are going to start with CATIA assemblies and we are going to see bottom up assembly. There are two types of assemblies basically. First one is top down and second one is bottom up. So we are going to start with bottom up assembly in which parts are made and saved first and then they are used for making assemblies. So in CATIA we can say an assembly is a collection of individual parts brought together to create a complete product or a mechanism. Each part can be designed separately and then assembled using constraints like coincide, contact, angle or offsets. So assemblies help engineers visualize how parts fit and move together to detect interference and collisions. So let's start with an assembly. We are going to make a press tool assembly today. For that we have made parts already and now we are going to just assemble them together. And now we are going to assemble them together by calling them one by one. So to start with, we have this first toolbar, that is product structure tools. So in product structure tools, we have this fourth option, that is existing component. For calling any part in bottom of assembly, you just need to click on this icon, that is existing component first. So I'm going to click on this icon. Next we need to click on this title of the assembly, that is product. Click on this product option and now we can browse the files. So I'll go to folder where I have saved the files on desktop, teaching data, and here we have the folder for the CATIA assemblies. First part we are going to call here is base plate. So for making press tool assembly, we have the reference of this PDF showing the press tool assembly. So here the parts are bottom plate, guide pillars, then guide bush, and lastly we are going to assemble top plate. So starting with bottom plate, we need to call the base plate or bottom plate first. So let's get started with the option existing component, say product, and browse for the part. So in teaching data, I have kept here the folder. Here is the part base plate. I'm going to say it open. We have made the part first and then saved them. And now we are calling them for assembly. So this is the base plate or bottom plate. As this is the first part, we need to see the directions of motion which are on here. For that we are going to expand the model tree here. For that we are going to click on this base plate, say right click, and below the delete option, there is the option named on part name itself. Just select, expand this arrow, and here we have components degrees of freedom. So it is showing me the degrees of freedom as 6 degrees of freedom, that are 3 rotations and 3 translations in the context of the product. So we need to lock all the degrees of freedom for each part here. That will be the main motive to make a complete constraint assembly. And for constraining these parts, we need to give the mates that are known as constraint here. So for every part which is the first part in assembly, we need to give this constraint, that is fixed component. So I'm going to select this fixed component and click on the part here. You can see the constraint has been applied as the sign is showing here. This part is fixed. Now as this part is fixed, again we'll check the constraints, degrees of freedom. Say right click, go below the delete option, base plate, and then component degrees of freedom. So now it is showing that there is no degree of freedom and the part is fixed. Now this fixed constraint we are going to use only for the base part or the first part which we have called for the assembly. Other parts which are going to be called for making the assembly, we are not going to use fixed component for that parts. That parts will be constrained by using different mates here or different constraints such as coincide, surface contact, offset constraint, angle, perpendicular and parallel. So these are all the constraints which we are going to use further. The toolbar name is constraint toolbar here. We are going to call the next part as this part is fixed and the fixed mate will only be used for first part. Just keep this note in mind. Now moving toward the next part, again we are going to select this option, that is existing component. Click on the product title and the next part we are going to call here is guide pillar. Here also we can see this base plate has been called and now guide pillar is to be assembled here. So we are going to call this guide pillar. We can see here this guide pillar is appearing. If I want to move this guide pillar aside, we are going to use this toolbar, that is move. In move toolbar we have this manipulation command. Select this option and now we can see this dialog box here. Now the first 3 options X, Y and Z are showing that we can move this part in X, Y and Z direction using these icons here. If I am clicking on this X direction along the X axis, this part will move only along the X axis, plus or minus side both. Then If I select this option Y direction, it will move only in Y direction, not in X or Z. If I use this Z option, drag along the Z axis, then it will be moved along the Z axis only. Same way, if I want to move it along the plane in 2D plane, maybe in XY plane, YZ plane or ZX plane, we can do that also by using this dialog box. So if I say drag along XY plane, means this part is going to be dragged only in X and Y direction. You can see here. So this is the X direction and this is the Y direction. In Z direction, we cannot drag it here. If I go for this option, drag along YZ plane, now this time it will be dragged in Y direction as well as in Z direction. In X direction, it is not going to be dragged. Same way, if I want to go for this three option, lastly three, that is drag around X axis, means we are going to rotate this part along the X axis, Y axis or Z axis. Or we can select any edge reference also here. So I'm going to select the X axis first. You can see here. Now it is rotating along the X axis. You can refer this axis system here for better understanding. Next, we are going to go for Y axis, rotate along Y axis. So now this time this part will rotate along the Y axis. You can see this Y axis here. It is rotating along that axis only. And lastly, we have the Z axis. So if I click on this option, it will rotate around the Z axis only. If I want to give the edge reference here, I can select this edge reference also. And now this part will rotate along this edge only. We can see this white line showing the edge reference. So other than the axis system, you can use the references also here. So we are going to keep this part aside by using X movement. Say OK. Now we are going to apply the mate here. First we'll change the appearance or view style. We are going to take the view style here as shading with edges without smooth edges. So these extra edges will not appear here. You can see the difference now. The extra edges which were appearing here are now disappeared. Next we are going to go. Now for assembling this part into this hole, there are some things to be followed while making this part. Means when you are making these 4 holes, they should be compulsorily made by pattern command only. Means this first hole will be extrude cut or pocket and pattern should be made for these holes. This hole should be made separately and not with these holes. So this was the first hole which we have made. For my reference, I always use lower left corner to make the first hole. So I'm sure that I have made this hole first. So I'm going to apply my first guide pillar to the first hole only. And then we are going to pattern this or assemble them by using pattern here for other pillars. Now other than this original hole, these 3 holes, if I have not made them by using pattern command, then assembly pattern can also be not used here. So in assembly, whichever part we are going to assemble here by using pattern command, that is reuse pattern, the related feature should also be made by pattern command only in part modeling, and then only we can make them pattern here in assembly. So it is compulsory for us to use pattern command in part modeling, then only the pattern command in assembly can be used. So I am going to assemble this first pillar into the first hole. Now for assembling them together, the first constraint we are going to use here is coincide constraint. Now coincide constraint is only used when axis to axis are to be matched, means the center of the circular parts will be matched together, or else the flat faces are to be coincide or made coplanar to each other. Only that time this constraint is going to be used. So I'm going to select, if this notification comes here, say do not prompt in future and say close. Now after selecting this coincide constraint and activating it, the axis will be highlighted by default only when you move this cursor towards the guide pillar. So I'm going to select this axis here and the first hole axis. Remember, out of these 4 holes, the original feature hole, that is the first hole, should be used for making the first guide pillar to be assembled. Other than the first hole, the other 3 holes should not be used. So the first hole was this one. For making sure, we are going to expand this model here, that is of base plate, and we can see this pocket. This pocket one is this first hole, and this rectangular pattern are the other 3 holes. So I'm going to assemble the first guide pillar to first hole only. We cannot use the other 3 holes for assembling the first guide pillar. This point should be noted very clearly, or else there will be errors while using the pattern command in assembly. So I'm going to assemble this with the first hole here. You can see these constraints are being applied But after applying constraint, we need to use this command, that is update. You can see the icon here. So the part will be at its updated position. You can see here. Next, we need to make this bottom face of guide pillar coincide with the bottom face of this base plate. So for that, again we have said, for flat faces we are going to use first constraint only, that is coincide constraint. So in assembly also, the bottom face of the guide pillar is matched with the bottom face of the base plate. So we are going to apply the mate here, say coincide constraint, select this flat face. We should select the face only, not the edges, or the different mate will be applied here. Means every selection matters here, whether you are selecting the face or whether you are selecting the edge. So it is very important that you should choose the proper selection. Then we are going to select the flat face here. It will ask you whether you want the orientation of this guide pillar on the same sides of the faces as the reference given, or on the opposite sides. Means this faces, the guide pillar bottom face and the base plate bottom face will be at opposite sides or connected with opposite directions. Whether you want that or you want them to be connected in same direction. So both the options are given. If I select same and say OK and update, you can see both of them are at the same direction, means no part orientation has been flipped here. Go in constraint. If you undo, still the mate remains here. So better after undoing you should check the constraint also whether it is undone or not, or else you need to delete it. So I'm going to delete it again and then go for the same mate to show the difference of opposite and same, both the faces, and this time instead of same we are going to select opposite. Say OK, and when we say update, we can see here this guide pillar orientation is being changed at 180 degrees. These two parts are being oppositely connected. So this is the main difference between same and opposite while using coincide constraint. Same thing will be done if I use this surface contact constraint. So I'll undo it again. And as I said, after undoing also you need to delete this coincide constraint and then only it will be vanished here. So if I use this command also, that is contact constraint, the only difference is between these two commands. In this contact constraint, same direction option is not there. Here the part will be connected in opposite phase directions only. So if I select this constraint, that is contact, select the faces here and say update, we can see the faces are connected oppositely, not in the same direction. So here we have same and opposite both, and here we have only opposite connections for the flat faces to be coincided. But we are going to undo it here and going to use coincide constraint with the same direction only. This flat face and this flat face with same direction and say OK and say update. Now this guide pillar is been positioned here. First axis to axis connecting the centers of hole and shaft, and then face to face connecting the bottoms of the two parts. Next we'll see whether the degrees of freedom for this part are completely locked or not. For that, just right click here, the model tree, on the title name, and here below the delete option, just go here in this arrow option, and here you will get component degrees of freedom. You can see here rotation is still on, and precisely rotation around the Z axis is on. We can see here in model area also, it is highlighted in yellow color that around Z axis this part is rotating. So we need to constrain this rotation also. For that we are going to use this command, that is angle constraint, in which we have three constraints: parallel, perpendicular and angle. So to start with, first select the constraint and we are going to use the references of the planes for the parts. So here for guide pillar these planes are given, and for giving references for constraint we are going to use planes of each part here. So for guide pillar these planes have been highlighted. For bottom plate these planes have been highlighted. So we are going to use guide pillar planes to lock the rotation of this guide pillar. So first part which was fixed means this face was also fixed. So I'm going to make this plane parallel to this face, and when the face and plane are being parallel, this rotation of this part will automatically get locked. So we are going to use that constraint. We can also make this plane perpendicular to this face. By that also we can lock the rotation. As the plane will be perpendicular, this part will not be able to rotate due to restriction of the perpendicular mate. And the third option is, if I make this plane angular with this face, By giving specific angle mate or angle constraint also, this plane will be locked and this part will not rotate here. So all the three options can be used. We'll see all of them one by one. So I'm going to select this plane here and this face. You can see this constraint properties highlighting the three mates or three constraints: perpendicular, parallel and angle. So here I'm going to apply the perpendicular first one, making this plane orange colored plane and this face perpendicular. We are using this face because it is fixed, as the part was fixed earlier, that's why. So I'll say update, and after updating we'll see this plane will be perpendicular to this face. Update, and here this plane now is perpendicular to this face. We'll see the degrees of freedom now. Go on guide pillar, right click, select degrees of freedom, and here will show there is no degree of freedom, means this part is completely constrained, having no degrees of freedom. That's what we need here. Say OK and finish. So if I delete the perpendicular, the other option is making this plane parallel to this face. So we'll apply parallel constraint here. Select the plane and face, say them parallel. Here also we have the orientation option, whether you want on the same side as parallel or opposite side. We can choose any one of them. Say OK here and say update to apply the constraint properly. And here we can see in constraint dialog box all the history of the constraint. Here it is showing now parallel mate has been applied. So one more time we'll check the degrees of freedom whether it is locked or not. So degrees of freedom is locked. Here the degrees of freedom will show. Now I'll apply the third option to see how to constrain this part by giving angle constraint. So I'm going to select this plane and this face, and now we are going to go for this angle constraint instead of parallel and perpendicular. We have already seen them. So here the angle we are going to keep is 45 degrees. For angle also there are sectors, means for placing them in each different quadrant. There are total 4 quadrants, so different 4 sectors have been given. According to the quadrant position you can select the sector here. I'm just giving 45 degrees in sector 1. Say OK and say update. So we can see this plane has been inclined by 45 degrees with reference to this face. So in this way we can apply this angle constraints here, having all the three options: parallel, perpendicular and angle. All the three results, this guide pillar will show degrees of freedom are locked. There is no degree of freedom in context with the product. This is the thing we need. Say OK and finish. So the first part was fixed. The second part is also fixed now, but not by applying the fixed constraint, but by using the different constraint mates here. So we need to fix all the parts degrees of freedom by applying different constraints. Only for first part fixed component will be applied, not for the other parts. Other parts will be made constrained by using these 4 commands only. So after making this guide pillar fully constrained, we are going to go for the preuse pattern command now, and we are going to pattern this guide pillar. Then later we are going to call the guide bush, and then we are going to repeat the same thing here. So to start with, we are going to select the reuse pattern command, select the part which we want to pattern, then expand this base plate feature and select the pattern here which we are going to use as a reference pattern for reusing. We are doing 3 selections here. First guide pillar selection, second this rectangular pattern selection, and then thirdly we are going to say generated constraint. So the constraints of this first guide pillar will be followed by the other pillars also. Say apply and OK. Now just for check, I am going to select any guide pillar except the first one to see whether all the guide pillars are fully constrained or not, or fully degrees of freedom are been locked or not. So right click on any pillar except first one, say right click, below delete option, select this option, expand and go to component degrees of freedom. Here we can see it is showing there is no degree of freedom for guide pillar 3. Means all the guide pillars are properly patterned following the constraints. Now the next part we are going to call here is guide bush. So for guide bush, select the existing component, select the title, select the part, say open now, and we are going to manipulate it, taking it into X direction first. So manipulation in X direction, and then we are going to move it little bit upper side, in Z direction also little bit. Say OK and finish. Now we are going to position this guide bush on guide pillar. Now one thing very important here, that this guide bush also should have the relation with the hole only, not with the guide pillar axis. So if I give constraint, that is coincide constraint between axis to axis, the axis of guide bush should be selected and the axis of this hole should be selected, not of this guide pillar. It is because if I want to reuse pattern again, I want the relation to be established between guide bush and plate only, not between guide pillar and guide bush. And if there is relation between guide bush and plate, then only I can use this reuse pattern. So for making the coincide constraint with access to axis of guide bush and hole, we need to hide this guide pillar. And if I don't do that, if I directly go for constraint, that is coincide constraint, select the axis of guide bush and select the axis of hole here, then the hole and guide bush axis are showing same as they are collinear. That's why we need to hide this guide pillar first and then go for the relation. So for hiding this guide pillar, I'm just going to right click it here, say hide. So if I hide one guide pillar, all the other guide pillars are also been hidden here. We'll show them later. First we'll maintain the relation between the guide bush axis and hole axis. Now this step is compulsory if you want to apply reuse pattern. And make sure that the guide bush also should be made with the first hole only, not with the other pattern holes. As the guide pillar was constrained with the first hole, same way guide bush should also be made constrained with the first hole only, hiding the guide pillar. Next, select the constraint, coincide constraint, axis of guide bush and axis of this hole. We'll zoom it little bit and then select the axis of the hole. Say update for making it proper position. Now we have the relation between guide bush and the hole. Means we are directly having relation with the plate now, which is necessary for reuse pattern. Then we are going to show the guide pillars here. So in guide pillar 1, expand this and go for this feature that was shaft. Just select and say right click and say show again. All the guide pillars are shown again. Next thing we are going to say offset constraint now. We can see here in assembly, the top face of the guide bush is at the distance from the top face of the guide pillar. We are going to assume this distance. I'm saying this distance here. So this distance we are going to take 20 mm. So this time we are going to use offset constraint. Offset constraint means applying distance between two faces, two planes, two parts, any two flat references. So I'm going to apply the offset constraint here. First reference as the top face of the guide pillar and second reference as the top face of this guide bush. Now as I have selected the first reference of the guide pillar and then the second reference of the guide bush, it is showing the minus sign here with the value. If I want the plus sign, I'll just escape, cancel it, again go for the selections, select the required mate or constraint, then select the face first of guide bush and then of the guide pillar. This distance is going to be shown in plus sign now. So I'm going to set 20 mm distance here on the same side, say OK. Next we need to update it here. Before updating, this value is shown in brown color, you can see here. But when we update, it is shown in green color, highlighting that the constraint has been properly applied by 20 mm. Now as we have applied the constraints, first was axis to axis by the plate hole and guide bush, then distance constraint between the top face of guide bush and top face of the guide pillar. We are going to go for checking the degrees of freedom for this guide bush. So right click on the guide bush in model tree and below delete option, just expand this and go in this arrow. Here the option is component degrees of freedom. And we can see 1 degree of freedom is still on, that is rotational movement. It is also been highlighted in yellow color here. So just close it and go for locking this degrees of freedom now. And then we are going to go for pattern. Make sure that before going for pattern, any part should be fully constrained or should not have any degrees of freedom. Then only we are going to go for pattern. If you don't lock the degrees of freedom and directly pattern the part, the degrees of freedom which were unlocked for the one part will be followed in pattern for other parts also. Means all the other parts will also have the same degrees of freedom as the part which we have used for reference of pattern. So we will log the degrees of freedom of this guide bush also. For that I am going to use angle constraint. Now we have two options. Either we can go for parallel constraint between this side face of the plate and this plane of the guide bush, making them parallel, or else we can go for making the guide bush plane, this plane, parallel with the guide pillar plane. So both things we can do here. I'm going to say parallel between the guide bush plane and this guide pillar plane. So select the guide bush plane here and the guide pillar plane for the reference. Go for parallel constraint at the same side, say OK and update. After updating, this plane will be inclined and parallel to the guide pillar plane. We can see here it is inclined now. Now all the degrees of freedom are locked. We can see here there is no degree of freedom. Now we can go for reuse pattern again. So again expand the base plate here for the reference of pattern selection, as the pattern was given in base plate. That's why we are going to expand it first. Then go for reuse pattern. Select the part or component you want to pattern. Select the reference of pattern from the model tree. And then third step is to generate constraints. Means the constraints of the first guide bush will be followed to the other guide bush also, making them fully defined or fully constrained. Say apply and OK. We'll delete this assembly feature, the second rectangular pattern. All the history of the assembly features will be shown in the assembly features tab. So we are going to delete this second pattern again. Just for repeating it, we will repeat the reuse pattern. First expand the model tree and base plate options where we have the rectangular pattern feature. Then go for reuse pattern command. First step is to select component. Second step is to select rectangular pattern. And the third step that is compulsory is to select the generated constraint and then say apply and OK. So here this guide bush are also been patterned now. Except first one, I can see any one of them, second, third or fourth. Just say right click, go for degrees of freedom to check. And here it will show there is no degree of freedom in the context of product 2. Means this complete part are been patterned as well as constrained now. Now I'll go for the last part of the assembly. Now for calling the last part, we are going to use existing component option, or else we can go for the other option also, that is existing component with positioning. Select that option, select the product, go for the selection of top plate. The difference between these two commands, that is first one existing component and the second one existing component with positioning. The difference is we will have this window here showing the part which we have called. Now here the base plate means bottom plate and top plate are being merged together as they were of similar sizes. That's why only the difference can be seen here is with this pillar which was not there in base plate or bottom plate. So it is difficult to select the faces directly from the assembly. That's why this window has been provided. If we use existing component with positioning, it will help you for direct selection of features to apply the constraint. So we can put on this option, that is automatic constraint, and directly apply the constraints here by selecting the features from this window instead of selecting the features from the assembly, as the parts are overlapped. So to avoid that only this feature is given, but I'm not going to use this one to apply the constraint directly. I'm just going to say it close, and we will use the existing component feature only. Select the product, again call this part top plate. It will be overlapped here. So the other option is to move this part aside and then apply the mates. So to move it aside, we are going to use manipulate command. First we are going to use Z direction. So the part will be dragged in Z direction here. I'll take it at downward sides, and then we are going to rotate it around X axis. So the orientation of this pillar will be at downside. So around X axis we are going to rotate it. Still we can see this pillar is coming at the back side and this hole is coming at the front side. So we need to rotate it again. So I'm going to select Z axis here for the rotation, and now it is oriented properly to give the constraints. Now this pillar is coming matching with the hole. Not exactly, but after constraint it will be matched here. So for applying any constraint, we are going to go for this option, that is coincide constraint. Select the axis as well as select the whole axis. Say update. Then go for this option. Select the coincide axis. We are going to make this axis of this hole of the top plate to be constrained with the guide pillar or guide bush axis. Coincide constraint. So we can select any axis out of bush or pillar. So I'm going to select this axis here. Now both the axes are been selected of the bush and hole. From top view we can see it is properly positioned. And now for lastly positioning it properly, we are going to refer the PDF. Here we can see the top face of the top plate is coincided with the top face of the guide bush. So both the top face of guide bush and plate are coincided with each other. We are going to do the same thing by applying the coincide constraint between the two faces. So I'm going to select here coincide face, top face of this part as well as the top face of the guide bush. Say update at the same sides, not opposite, as the orientation will change if I go for opposite. So same side, say OK and say update here. And now finally this assembly has been constrained. So we have seen all the important constraints here, that is coincide constraint, opposite face contact constraint, surface contact constraint also we can say. Then for distance we have seen offset constraint, and for proper orientation we have seen angle constraint, parallel constraint as well as coincide constraint in the same command, this command. We have applied the fixed component also, and lastly we have used the reuse component. So in this way the press tool assembly part has been completed. Now we'll hide the planes here, as it is very hectic to see the parts here and to visualize them properly. So for that, for hiding the planes, just go on this view tab, this toolbar, go for this option, that is custom view parameters, and here say no access, say OK and finish. So the planes, all the planes will be hidden here. Next thing, if I want to edit any part, so I just need to select the part in the model tree. We are going to take the example of base plate, expand the features of the part which you want to edit. Go for the first feature with the settings symbol and double click on the name. And here we can see this interface, now it is coming as part modeling interface. So whatever things I want to change in the base plate or bottom plate, I can change it here. Now after applying the changes and moving to assembly interface again, you just need to double click on this product title, and in this way you will be moved again to assembly interface. Suppose if I want to edit the size of this pillar of top plate, so I'm going to expand it, double click on the title here after expanding, and this change interfaces of part modeling now. So if I want to change the size of this guide pillar, I'll just expand it again, go for this pad, double click on this pad, and here I will change the value from 80 to 100 or 120 I'll say, just to show the change properly. Say preview, and you can see this part has been updated. I'll change it to again 80 again, say OK. So it is moved little bit upward now again. We'll move to assembly interface by double clicking on this product title. So here we can see the toolbars of assembly features again now. Things important to note, we have used toolbar, that is move, constraint and product structure tools. These are the main three toolbars which we have used for assembly. So this was the basic lecture of assembly today. We have seen the bottom up assembly interface. We have seen how to assemble them by using the main mates or constraints. We have also seen if there is reuse pattern, how to relate the component with the part which is having pattern. We have also seen manipulation command, use of this compass, and we have seen how to see the degrees of freedom. Make sure that all the degrees of freedom are locked here. Suppose if I go for top plate lastly, see the degrees of freedom, there is no degree of freedom. This assembly is fully constrained now. Now suppose if I want to apply the appearances for the part, I'll just expand this in model tree, select the part modi, right click, go for properties. Here we can apply the appearance we need, say apply and OK. So for other parts also, directly don't go for properties on this title name, first expand them, then go for the part body, then select the title name or properties option, go for graphics, and in graphics window you can apply the appearance you require, say apply and OK. Next for the guide bush, again expand it, expand the feature, select the part body, go for properties, go for graphics and apply the graphics you want. Lastly the top plate, expand it, go for the part body, right click properties and graphics window, select the feature, say apply and OK. So here the assembly has been completed now. So that's all for today's lecture. We'll continue with the assembly features and remaining commands of assembly in later lectures. We are also going to see top-down approach for the assembly. So stay tuned in the channel 4 Dimensions Infotech and keep watching the videos for CATIA series. Till then, thank you.